If we have an equation like x squared minus 4 equals 0, there's two ways that we can solve this. Okay, so the first way, we can factor this. Since this is difference of squares, we could take the square root of x squared, which is x, the square root of 4, which is 2, and we could write this as x plus 2 and x minus 2 equals 0. And then we can set each one to 0 and solve. So x plus 2 equals 0. We end up with x equals negative 2. And then x minus 2 equals 0. We end up with x equals positive 2. The second method we can use is just solving for x. So if I have this equation, I can get my x squared alone by adding 4 to both sides. X squared equals 4. And then I can take the square root, and I end up with plus or minus 2, which gives me the same answer. So the left-hand side of this equation is called a perfect square trinomial. What that means is that it's two factors that are exactly the same, getting multiplied by each other. So x plus 2 squared, if I FOILed that out, if I wrote x plus 2 and x plus 2 and I FOILed it out, that would give me x squared plus 4x plus 4. And that's equal to 9. So once I get a perfect square on one side of my equal sign, I can take the square root now of both sides. So when I take the square root of x plus 2 squared, the square and the square root are going to cancel out, and I just get x plus 2. And the square root of 9 is plus or minus 3. So I have two answers here. I have x plus 2 equals positive 3, and if I solve this, I get x equals 1. And my second answer is when x plus 2 equals negative 3. So since 3 was plus or minus, we have to break it up into both of the answers. So if I solve this and I subtract 2, x equals negative 5. So a way you can check this also is the original problem, if I set it to 0, so if I subtracted 9, I would end up with x squared plus 4x minus 5 equals 0. So if I factor this, what multiplies to negative 5 and adds to 4, I would have x plus 5 and x minus 1 equals 0. And then when I solve each one, I get x equals negative 5, and I get x equals positive 1, which are the two answers that I got from the other way. Now the other way is a little bit faster. You don't have to factor. You just get a perfect square, and then you take the square root. So what if you have something like x squared plus bx? You can make a perfect square trinomial from two things. So that's called completing the square. So basically what you do is you take your b term. So in this case, it's 18. You divide your b term by 2. So that gives me 9. And then you square it, which gives me 81. So 81 is the missing number. Once I put 81 there, x squared plus 18x plus 81 is a perfect square trinomial. And the way that we can figure out how to write this as a binomial squared is that whatever number we got when we divided by 2, so this number, this 9, since it's a positive 9, we would write it as x plus 9 squared. And you can always check this by writing it twice and FOILing it out. So we completed the square, we put the 81, and that's our binomial squared. So if we look at another example, so here our b is negative 24. So we're going to take the negative 24, divide it by 2, we get negative 12. We square it, we get 144. That's the number that we put at the end. So now that's a perfect square trinomial. The number that we got when we divided by 2 was a negative 12, so it's x minus 12 squared. Right? And then this last one, negative 3, we divide it by 2, and we get negative 3 halves. And then we square it, and we get 9 fourths. So when you square it, you're squaring the top and the bottom. So 9 fourths is what we add at the end. And then the number we got when we divided by 2 was negative 3 halves. So x minus 3 halves squared. Now we can use this idea to solve quadratics that we might not be able to factor. So what we want to do is we want to rewrite the equation so that the x squared and the bx term are on one side, and any c value that they give us, we move to the other side. Then we complete the square on the b, and then we add it to the left-hand side, and then we also add it to the right-hand side. So in math, you want to always make sure that both sides of the equation are equal. So if you add something to one side, you have to add it to the other side as well. Then the left side becomes a perfect squared trinomial that you can write as a binomial squared, and then you take the square root, and then you solve for x. So here's an example. So we look at the first one. We want to get the ax squared and the bx term by itself. So first thing we want to do is move this 3 to the other side. So we have x squared plus 6x. I'm going to leave a space, and I'm going to put equals 3. So now we're going to complete the square on the 6. So the 6 comes down, we divide it by 2. We get 3. We square it, and we get 9. So we're going to add 9 here. We're also going to add 9 on the other side. So now the equation is balanced. We added 9 to both sides, so it's equal. The left-hand side, we can now write that. We're going to use that 3, and it's going to be x plus 3 squared equals 12. So now we're going to take the square root of both sides. So we end up with x plus 3 equals, and we're going to break down square root of 12. So it's going to be plus or minus, and the square root of 12, if you need to write it down, 12 becomes 4 and 3, and 4 is 2 and 2. So we have a pair of 2's on the outside and a 3 on the inside. Last step is to get x by itself, so we want to subtract 3. And the 3 on the right-hand side that we're subtracting, you can't combine it with anything, so we're just going to write that as negative 3 plus or minus 2 radical 3. Okay, if we look at the second one, now we have an x on the right and an x on the left, so we want to make sure that we have every x term on the left-hand side. So first thing we're going to do is subtract x. So we have x squared minus 4x, I'm going to leave a space, equals negative 1. So we're going to complete the square now. So I'm going to take the negative 4, divide by 2, so I get negative 2. Square it, I get 4. I'm going to add 4 on both sides. So now the left-hand side, I'm going to use that negative 2, so it's x minus 2 squared. The right-hand side, I have 3. And now I'm going to take the square root. So x minus 2 equals plus or minus root 3. And then I'm going to add 2. So this ends up being x equals 2 plus or minus radical 3. Okay, and then this last one. So in this case, we could take the 2 out. There's a GCF. So anytime there's a GCF, okay, we want to first put it in the right form. So even though the 6 can be divided by 2, you want to move that over first. So we have 2x squared minus 10x, and then equals negative 6. So we're going to take the 2 out of just the left-hand side. So the 2 comes out, and we have x squared minus 5x. I'm going to leave a space, equals negative 6. Now this part can get tricky because if you take a value out first, you have to take that into account when you're adding your numbers back in. So what I mean by that is I'm going to complete the square on the negative 5. So negative 5 divided by 2 is negative 5 halves. I'm going to square it, and I get 25 fourths. So I'm going to add that over here, so plus 25 fourths. But because there's a 2 on the outside, if I distribute the 2 back in, 2 times x squared is 2x squared, so that matches up. 2 times negative 5x is negative 10x. So I also have to do 2 times 25 fourths. So that's just 25 halves. So what I'm doing on this side is I'm adding 25 halves instead of 25 fourths. Okay, so I physically wrote 25 fourths on the left-hand side, but because of that 2 being on the outside, the actual value that I put there is 25 halves. So I'm adding 25 halves to the other side as well. So now I have a 2 on the outside. I'm going to rewrite that perfect square trinomial as x minus 5 halves squared equals, and then negative 6 plus 25 halves is going to be 13 halves, because we're making the negative 6 into negative 12 halves. So now we want to divide by 2. So we end up with x minus 5 halves squared equals 13 fourths. And then we're taking the square root. So this one's a little complicated. So the left-hand side is x minus 5 halves. And then the square root of 13 fourths is going to be plus or minus the square root of 13 over 2, because the square root of 4 is 2. And then we want to add the 5 halves. So our final answer would be x equals 5 halves plus or minus radical 13 over 2.